Most of this demonstration will be performed using only a single tool, a web browser. One of the benefits of using web-based technology like this is that it eases adoption. Users don't have to install or learn how to use new desktop clients. Everyone already knows how to use a web browser. The only time we need a desktop client is if we're trying to do something a little more complex, such as code generation or model execution. And you'll see that later. Here we're looking at the product breakdown structure, in this case for the base variant of our product. The overall aviary system has a set of requirements, design models, and tests. Then that system is broken down into the hummingbird, the bird feeder, and the bird watcher. If we expand one of those systems, the hummingbird, that system has a set of requirements, designs, and tests, and itself is then decomposed into subsystems, avionics, comms, and so on, and those also have requirements, models, and tests. We can navigate into any part of the system definition from this view. Later we'll look at the requirements, the designs, and the tests, but let's start with how we plan, manage, and track the work. We're now in IBM Engineering Workflow Management, or EWM for short. And this is where we manage the work, the plans, the tasks, defects, project change requests, and so on. As I mentioned in the introduction video, the aviary system has been built using SAFe, or Scaled Agile Framework. And so we actually have multiple workflow management projects at different levels. This one is at the large solution level, and we're looking at our solution team's dashboard. Dashboarding is a common capability across the platform. Dashboards can be created for the project or for teams, or personal dashboards can be created for individual users. Dashboards give instant access to the project data that's most relevant to you, whether you're a test engineer looking at a current defect list, or maybe a project manager looking at the current status of the project. On this dashboard, you can see there are various widgets showing planning information for the solution level. Here at the bottom left, we have a list of the solution epics and the capabilities. But there is also actual work being done, requirements being written, systems engineering models being designed, and so on. And those tasks are shown here in graphs, by priority, by program increment, by owner, and by status. And we can click on any one of these graphs to drill down into the detail. Engineering Workflow Management deals with the day-by-day, hour-by-hour tracking of progress. The details are all captured by the tools themselves, so no more filling in spreadsheets. And that's less work for the engineers and live, always up-to-date information for project managers. Let's now drill down into Program Increment 1 and take a deeper look. Here we can see the solution roadmap, the breakdown of the high-level solution epics into capabilities. If we expand a capability, we can see a roll-up of how the features from the program-level workflow management project contribute to these capabilities, and even how those features are further broken down into stories at the team level. There are also tasks at this level to develop a systems engineering model for the aviary. If we open this System Requirements Definition and Analysis task and look at the Links tab, we can see other artifacts across the lifecycle that are connected to it. And if I hover my mouse over this linked requirement, we can see another common capability, something called Rich Hover. Whenever we have a link to another engineering artifact, we can see key information about it right here. We don't need to open the other tool that the artifact resides in, and we don't need to work out where that artifact is. Now that might be a requirements engineer looking at a link design, or a test engineer looking at a requirement they're testing against. It's a huge time saver. Now of course this is also a hyperlink, so I could actually click it to navigate to that link requirement directly. Now we'll do that later, but instead let's go back to our plan. There are other ways to view and work with these artifacts. For example, this solution Kanban board shows the capabilities and their current status, visualizing the flow and allowing the team to minimize bottlenecks. We can change the status of a capability simply by dragging it between columns. Engineering Workflow Management can also impose tight process control. For example, in SAFe, the work in progress limit restricts the maximum amount of work in the different stages of the workflow. If I try to drag another capability into the analysis column, then EWM won't allow it. The work in progress limit has been reached. This allows teams to complete single work items faster by helping them focus only on current tasks, and gives them the opportunity of locating bottlenecks in their working processes before they become blockers. This WSJF view, or weighted shortest job first, allows the team to focus and select the most vital tasks to implement, those that produce the most return for the business. WSJF takes factors such as business value, time criticality, risk reduction, and so on, and combines them using an algorithm that gives us a clear view of which tasks to prioritize. Let's go back to the solution roadmap view, and let's click one of these features. Now, engineering workflow management tells me that even though I'm viewing the details of this feature here at the solution level, it's actually owned by a different workflow management project at the program and team level. And we can follow this link to open it in that project. We're now in the program and team management project, and these guys have their own dashboard, tracking things like user stories. Let's take a look at one more useful feature here, the program board. This gives us a visual summary of tasks, features, or goals, when they need to be achieved, and critically, if there are any dependencies that might impact their delivery. This view is all about the management of those dependencies. Let's take a look at two examples. Over here on the right, this tells me that one of the stories under feature 2149 is planned for sprint 1.5. It's owned by the avionics team, and it has a dependency on an earlier story, one that sits somewhere under feature 2148, which is taking place in sprint 1.1. Now that's green, because that kind of dependency is absolutely fine. By the time we get to sprint 1.5, that other story should be complete. Now, of course, we can filter those things out if we want to. But here in sprint 1.2, one of the stories under feature 2149 has a dependency on a story under feature 2300, and that story is not planned to be done until a later sprint. What's more, that story is owned by a different team. Now that's a project risk. One of the really powerful features of this kind of view is not only that you can visualize these potentially complex dependencies, but the view is actionable. We can identify a project risk and do something about it. Let's expand feature 2300, and we can see there are 3 stories underneath it. If we expand this one, we can see the other story that depends on this one, the one that's causing us a problem. Now in this view, we can reschedule either of these stories. Let's push this story out to a later sprint. Now that dependency turns green. We still have a cross-team dependency, but now it's much less of a project risk. Okay, that's enough planning. Next, we're going to look at requirements management.